Nuclear energy. The physical process in which the nucleus of an atom is changed, releasing tremendous amount of energy in the form of heat and light. This is called nuclear energy or atomic energy. Now, the nuclear energy is divided into two types. First, nuclear fission, and second, nuclear fusion. So, let's first start with the nuclear fission. Nuclear fission, that the word suggests, fission. Fission means splitting up into two or more parts. That is, if the word nuclear is attached, then in this case, the nucleus of an atom is split up into smaller parts. Now, let's see the process behind the nuclear fission. What happens in this, that when the low energy neutrons are bombarded with the radioactive atoms, the radioactive atoms are uranium, plutonium or thorium. So, when these radioactive atoms are bombarded with the neutrons, then they get split up into smaller nucleus. These smaller nucleus are different from uranium. Now, in this case, when the smaller nucleus are generated, then apart from it, the neutrons and tremendous amount of energy is also generated. This energy which is generated is in the form of heat and light energy. Now, I have told you that the neutrons are bombarded and neutrons are released. So, what are these neutrons? As you all know that neutrons are the subatomic particle. These subatomic particle has a mass of 1 AMU, that is 1 atomic mass unit, with charge 0. So, the charge is 0, that is, it is neutral. So, the word comes neutron. This neutron has a very important role in order to carry out the nuclear fission reaction. The neutron is used to bombard with the radioactive atom, while in the reaction, the other neutrons are generated. So, one neutron is consumed and in the other hand, the neutrons are released. So, the neutrons plays a very vital role. Now, let's see the uses of this nuclear fission reaction. The nuclear fission reaction used as a tool for making nuclear weapons. Apart from it, the nuclear fission is also used to generate electricity by using nuclear power plant. In the nuclear power plant, the uranium, that is the radioactive atom, acts as a fuel in order to drive the electricity from the power plant. Now, let's start with the nuclear power plant. This power plant is basically based on the principle that from the nuclear fission reaction, the amount of heat energy which is generated is used to run the turbine. The turbine is connected to the generator. When the generator drives, then the electricity is produced. So, now let's start with the nuclear power plant. From the diagram, you can see that there are various construction blocks. We are going to discuss one by one all of the construction blocks. Now, let's first start with the reactor. In the reactor, you can see that there are several rods inserted. First, let's talk about the fuel rods. These fuel rods are basically made up of uranium. The uranium is a radioactive element which is used to carry out the fission reaction. So, when this fuel rod is inserted inside the block which you are going to see is made up of graphite. So, these are called graphite block. The graphite block are also called moderator. These moderators are used to slow down the neutrons in order to initiate the fission reaction. So, when the fuel rod is inserted in the graphite block, then the fission takes place, and in this nuclear fission, the neutron and tremendous amount of energy is generated. Now, what happens? That when this tremendous amount of energy is generated and the neutron are also produced, then this neutron is produced in a chain. That is, if one reaction gets complete and the result is the number of neutrons, so that neutrons is used to initiate the other heavy nucleus, and like this the chain continues and the reaction goes out of control, which is the part of the atom bomb explosion. So, when the nuclear fission reaction goes out of control, that is the number of neutrons keeps on generating and it drives the other heavy nucleus, then in that case some controlling power is required. In order to control this nuclear fission reaction, the boron rods are used. This boron has a property to absorb the amount of excess neutrons. So, you can see in the diagram that Adjacent to the fuel rods, the control rods are provided, and these control rods are boron rods. Now, when this setup is completed, then this setup is inserted inside the steel vessel of a reactor. Inside this reactor, the nuclear fission reaction takes place, generating tremendous amount of energy. Now, from the diagram, as you proceed, then you can see that there is a coolant pump. This coolant pump is used to provide the liquid sodium inside the reactor. When this liquid sodium goes inside the reactor, then due to the heat energy which is evolved by the nuclear fission reaction, it converts it into hot sodium. So this hot sodium passes through the pipe and moves to the heat exchanger. In the heat exchanger, you can see that it is filled with water. When the hot sodium is passed through the pipe into the heat exchanger, which is filled with the water, then the water absorbs the heat energy of the hot sodium, and the water starts boiling and produce large amount of steam. This steam passes off and it is used to drive the turbine. The turbine is connected to the generator and thus the electricity is produced. Now you can see that when the hot sodium flows down through the water, then it gets cooled and it is connected again to the coolant pump, and thus the process starts. Again, the coolant sodium is inserted into the reactor and it again passes through the heat exchanger and the process continues. Now, the steam which is used to run the turbine, there occurs some unused steam. This unused steam passes to the condenser. The condenser is placed there, which is used to cool the steam and convert it into water. The water from the condenser is connected to the heat exchanger. So, the steam which is converted into water passes through the condenser into the heat exchanger. So, this is how the circulation of water continues. If the water gets circulated, then that water remains at a lower temperature. If the water remains at a lower temperature, then it can easily convert the steam into the water. So this is how the nuclear power plant works, and the uranium which is used as a fuel, once it is filled, then it continues the process. You don't need to refuel it again and again. Apart from this, the nuclear fission reaction is radioactive in nature. That is, it is very harmful for the living beings. As we all know that when we talk about the nuclear energy, then the second thought that comes to our mind is atom bomb. So, yes, the atom bomb is a part of this nuclear fission reaction. In the atom bomb also, the nuclear fission of uranium or plutonium takes place. And this reaction, when takes place, it is made to carry out so that it becomes out of control. When this reaction goes out of control, then it produces tremendous amount of energy in the form of heat and light. Yes, this is the atom bomb which is dropped on the Hiroshima and Nagasaki, where it caused the destruction of life and property. So nuclear fission is beneficial to generate electricity, but on the other hand, it is very harmful for the living beings and for the environment also. Now let's see the nuclear fission reaction. In the nuclear fission reaction, the heavy molecules are bombarded by the neutrons, releasing the smaller nucleus. Apart from that, the neutrons and tremendous amount of energy is also released. Now, the reaction states that when the heavier molecule is a radioactive atom which contains uranium, plutonium and thorium. In that case, we have taken a nuclear fission reaction with uranium. This uranium has a mass number of 235 with atomic number 92. So when this uranium is bombarded by the neutron has the mass number 1 while the atomic number is 0. So when this neutron is bombarded by the uranium, then it decomposed or it produces smaller nucleus. These smaller nucleus are produced, which is called barium and krypton. The barium is produced in this reaction with the mass number of 139 and the atomic number is 56. Apart from it, the second smaller nucleus is produced with the mass number 94 and atomic number 36. Now, apart from these smaller nucleus, the neutrons also are generated. So, the neutrons are also generated, and it also releases the tremendous amount of energy. Now just see the reaction and balance the total atomic number in this side of the reaction and the total atomic number on that side of the reaction. Likewise, you have to see the mass number also. In this particular side of the reaction, that is, and this side. Okay, the atomic number, the total atomic number at this particular side is 92 plus 0. That is, total atomic number is 92. Now check out the mass number. The total mass number at this side of the reaction is 235 plus 1. That is 236. This is represented as the mass number and this is represented as the atomic number. Likewise, check this side of the equation for the same particular notation. Now, at the right hand side also, you have to check for the atomic number and the mass number. So, this is the right hand side of the equation. So, at the right hand side, first find out the total atomic number. The total atomic number at this side is 56 plus 36 plus 0. That makes 92. So, the number 92 is the total atomic number at the right hand side of the equation. At the left hand side also the atomic number is 92. So, both are balanced. Nothing is required. Now, in the same case, you have to check the mass number. Now, check the mass number at the right hand side of the equation. Add all the mass number. 139 plus 94. That makes what? 233. Now, the 233 is the mass number, but here you require 236. There is a difference of 3 more mass number. For that 3 more mass number, we have to release 3 neutrons. If we release 3 neutrons, then on adding 233 plus 3, that makes 236. It balances the mass number at the left hand side of the equation. So, the mass number now after balancing becomes 236. So, you can check out both the atomic number and the mass number are balanced. That is, this is the equation of the nuclear fission carried out by the uranium.